Well, good morning. We finally got this open and running. Let's get the slideshow set from the current slide, and we will go from here. First, I want to know any questions from anything we've done so far. And just for people who happen not to have been in class today, I did pass out to the students who were here. I didn't pass out, but I passed out to the students who were here. Oh, and let me get this changed too. So many things I have to go through here. Okay. I did have a student in one of my other classes who detected something that I had sort of seen but didn't understand, and they disappeared on us. There are some little icons down here you don't see now, but as I get close to them, you see them. And these are ones that then I can do the pencil and things a little bit faster than going through all the steps I did before. So appreciate having good students who know how to deal with this kind of stuff. Okay, so let's see. Are any of these white pages? I don't think they are. They don't show what they are. So I think I still have to go through that. Okay, there's any shortcut for that. All right. Any questions? Anything we've done so far? All right. Example 3, completely factor the following. Yeah. All right. Let's see if I can. There we go. The trouble is, this is aggravating. The thing I want to click on is this, and that stops the recording because it's underneath it. So I don't know if I can get this to move or not. Are any of you familiar enough with this to know that? I don't think it's going to let me. So I'm going to go with the next best color. I don't know what color that is, but it looks dark enough. So factor these completely. X plus 3 squared minus y squared. Can we even do that? Yay or nay? What do you think? Say again? Yeah, we got a cheerleader here. Okay, good. All right. How do we do it? What is it? That's a subtraction sign. That means this thing is a difference, and these two things are perfect squares. Same way we've done it before, except this isn't just a single letter or a number that's a perfect square. It's an entity that's square. Well, guess what? We can deal with entities, can't we? So what would be a guess? I mean, make a guess. How would you do this? X plus 3 minus, second. Okay. You're going to, let's see. What's that? Okay. All right, all right. Now I got to get my, still slow, but it's faster than it was. Okay. X plus 3 times X plus 3 minus y times y. Is that what you were thinking? Now what? Still hasn't factored it. It factored the first term of it, but we want to factor the entire binomial. How do we do this? Difference of two perfect squares. It was a long weekend, wasn't it? A lot of football. We only had one day last week. So easy to forget. Okay, how do we do this? Say again? Okay, it's kind of like division. Difference of two perfect squares is the sum times the difference of what? The square roots. Say again? Okay, x plus 3 here and x plus 3 there, and a y here, and a y there, right? The sum times the difference of their square roots. Square root of x plus 3 squared is x plus 3. Square root of y squared is y. Square root of, same thing here. Now, I really don't need the extra parentheses there. I just put them there for emphasis, okay? So, in effect, I could do away with those. I don't know why the pen is written that way, but so we really didn't need those. All right. So this is your answer. There's not much way to improve that. It's a little sloppy, so let's just write it closer together. X plus 3 plus y times x plus 3 minus y. Pull them a little bit closer together. That's how you factor. Does that make sense? Second? Okay. Do you remember how to do a squared minus b squared? Factoring that. This was last week. You're still doing the same stuff, okay? How do you factor that? Say again? A minus b times a plus b. Very good, okay? And guess what? In this problem, the a is x plus 3. So put it down, okay? Right there, x plus 3. Minus, and what's your b? Y. X plus 3 minus y times x plus 3 plus y. Plus y, yeah, exactly. X plus 3 minus y times x plus 3 plus y. We reverse the order, but it doesn't matter. Okay? Because multiplication is commutative. Go either way. Does that make it any better? All right, good deal. Any other questions on this? Yeah, it's a little bit of a new wrinkle. They just do it to try to confuse you, but you can't be confused. Y'all are too good for that, right? All right. So that's that one. Let's do this one. Now, I think this might take a little more. Nah. Yeah, let's go on. Splurge and do it on the white page. Okay. I'm going to see if I can splurge, okay. There we go. Nope, it didn't work, did it? No, it won't erase all this. Okay. Hey, going the wrong way. All right. Got to get back to a new white screen. Sorry about that. Let's do the B one. 4x squared minus 2y plus 1 squared. Can we do that? How? Say again? 2x. Oh, wait. Oh, I see what you're doing. You're doing the 2y plus 1. Let's do 2x plus 2y plus 1 times, let me see, okay, 2x minus 2y plus 1. Very good, okay? Notice how I've got parentheses and brackets. It doesn't really matter. This is square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Very good. Now, this first set of extra parentheses, because it's got a plus in front of it, you can just lose those. Okay? So let's just lose that one and that one. However, the second set, and I'll get this back and make it look like before the earlier ones. Okay? The second one, don't lose it, because it's preceded by a minus sign. A plus sign in front of a set of parentheses doesn't do a thing to it. The minus sign in front, though, what does it do? Change the sign of each term in the parentheses. Okay? So, we got a little bit more work to do here. We can go back to parentheses if we want to. What would this be? 2x plus 2y plus 1 times 2x minus 2y minus 1. Y'all are good. There, it's done. Can't take it any further. Okay? So anytime you have a difference in two perfect squares, the sum times the difference of their square roots, and then, especially if you've got this second term being a minus, following the minus sign, be careful with that. This one didn't bother you at all. The plus sign doesn't change anything. The minus sign changes both terms inside. Okay? Does that make sense? All right. We did one with a binomial in front. We did one with a binomial in the back. Let's do one with binomials on both ends. X minus 1 squared minus x plus 4 squared. Can we do that? Sure we can. How? X minus 1? What about it? Oh, okay. I take it you're doing them like this. X plus 1, okay, that's fine. Now again, you notice, since it's leading the problem, I don't have to put them in parentheses by themselves. They're fine. It's X plus 1. Wait. No. If that's what you said wrong, sorry, okay, here's what's wrong with it. You don't change that, okay? Sorry about that. It's an x minus 1 here. That doesn't change when you're splitting it up to do the factorization.
See, that's the part right there where it's confusing me. Like the first problem would be one side, and the other side.
Right.
I was doing the x minus 1 and x plus 1 to get it squared.
Okay, remember, let's go back to our sample. A squared minus b squared. What is your a in this problem? X minus 1. And that would be a plus b times a minus b. You don't change the a. You change this sign that follows it, but you don't change the a. Because that a stays a, right? That becomes a plus 1, b times a minus b. Okay? The a stays the same. Your a here is x minus 1. That doesn't change. What changes is the sign here. One's a plus and one's a minus.
I was thinking about factoring out and x minus 1 squared.
Okay, x minus 1 squared is x minus 1 times x minus 1. Not x plus 1. Right? Yeah. Okay. Good thought. What goes next? 1 plus and 1 minus, right? So we can do a plus here, or it doesn't matter where you do it, and we'll minus there. Then what? X plus 4 is perfectly fine here, but what do you have to do on the other side? In parentheses, x plus 4. Why is that? Because of the minus sign. If you got a parentheses in front, no sweat. If you got a plus sign in front, no sweat. If you got a minus sign in front, sweat. Okay? That means you put it in parentheses. All right? Simplify that first factor. What does it become? Okay, you can simplify it more than that. Well, we can still write it. Okay, x minus 1 plus x plus 4. We'll come back and do that next time. This one will be x minus 1 minus x minus 4. Very good. Now let's simplify each of them. Can we simplify what's in the parentheses on the first one? That's a plus sign, right? What's x plus x? No, that's x times x is x squared. X plus x is 2x. Excellent. Excellent. Okay. Okay. 2x plus 3. Very good. Times negative 5. The x's disappeared. So then we can simplify that a little bit to be, we can multiply back 3. You don't have to, but minus 10x. Well, yeah, let's not. Let's just leave the minus 5 out front. Since we're factoring, let's not go unfactored. Okay. We'll just leave that as that. Let's see how the book left it. Okay? By the way, the first one we already erased was x plus 3 plus y times x plus 3 minus y. Y'all got that one good. The second one was 2x plus 2y plus 1 times 2x minus 2y minus 1. Did that one well. And this one is 2x plus 3 times a minus 5. I started to go back and multiply through, but we're factoring, so let's not do that. Good deal. Now, do any of you get a little upset? Well, where's the video? Is it fair to lose my x's here? That doesn't seem right, does it? Well, it's sort of okay, because guess what? If you had multiplied out this binomial squared, be it x squared minus 2x plus 1, minus, square that one, x squared plus 8x plus 16, you have an x squared minus x squared, they disappear, and you just have a linear form. Yeah, we almost should have expected that. Okay? A little tricky, but it's okay. Any questions on that? Make sense? All right, that was example 3. And I don't think they're going to let me erase all slides, so I go to screen. So I have to do it this way. Unwhite the screen, and then come up with another white screen. Strange but true. All right, example 4. Completely factor this. 2x squared minus 50. Can we do anything to that? What? Oh, excellent, excellent, excellent. Always, always, always look for common factors first. Common factor of 2, and then what do we have? X squared minus, got a factor of 2 out of that too. Oh, out of 25, okay. Are we through? Why not? And what does that break down to? X plus 5 times, second, x minus 5. Y'all are good, okay? Now, warning, don't forget the 2. It's still a factor. Hang on to it. Later when we do equations, maybe you can get rid of it. Not with just factoring expressions. Can I get your name, please? Oh, you were already here. Sorry. Didn't see you leave, so, okay. How about this one? 9x squared minus 36. Now this one, that is a 9. It probably doesn't look like it. Let me see if I can make it look a little better. Not looking good either, but it's better than what? Can you do that? How? Second? All right. Now, I heard 2 different things. Go with the factor out 9 because that's the greatest common factor. If you do that, you save yourself some grief and maybe a few little errors too. Factor out of 9, what do you have left? X squared minus what? Are you through? How do you proceed? 9 times x what? Plus 2, x minus 2. Y'all are good. Okay. Now, I thought I heard someone starting, that first one's a difference of 2 perfect squares, isn't it? So why didn't we do that first? We could have. That would have been a what? 3x plus what? A little louder. 6 times 3x minus 6. Are we through? Looks like it, but we're not. Yes, you got to do in 2 places now. You got to take out a 3. This will be a 3 times x plus 2 times 3 times an x minus 2. Okay? And then get the 3's together, and that'll be 9 times x plus 2 times x minus 2. You get the same answer, but I think a little more work. And now, if I told you before what I think a good mathematician is, a little bit lazy. So I don't like to do extra work, okay? I like to do it. And usually the best rule of thumb, factor out those common factors first. That makes the rest of it problem usually a little bit easier, okay? Good deal. Any questions on that? Okay. You saw how we got the 9 out. Is that right? Okay. Then you had the 9 out, and then you had an x squared minus 4. That's a difference of 2 perfect squares. 4 is a perfect square of 2. 2 squared is 4. Okay? Now, you may not have been here the day I did this. Here's a suggestion I made to everybody. Write down numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could do 11 and 12 if you had room. Okay. Okay. Let's call that what? N, or whatever you want to call it. Then do n squared. What is 0 squared? 0, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100. You like that number, don't you? Okay, all right. Now, get to know them, okay? Recognize them. Realize those are your perfect squares. Now, for what we're going to do next, we do one more step. We do what n cubed is. What in the world is n cubed? Well, isn't n cubed n times n squared? Yeah. So an easy way to do this is you already started the table. Just do this number times that number, and 0 times 0 is 0. You don't really have to do that much. I just did it for fun. 1 times 1 is 1. 2 times 4 is 8. 3 times 9 is 27. 4 times 16 is 64. 5 times 25 is 125. And boy, after this, they get a little harder. I think it's 216 or something like that. And then you keep, after that, I don't really care anymore. They just get too big a numbers, okay? You could do them, but, I don't think you run into any like that. Okay. So, get to recognize your perfect squares. And what we're going to do next are perfect cubes. Sort of get those sort of fixed in your mind so you know what they look like. Okay? And that way, you see, when you saw that x squared minus 4, you say, wait, 4 is a perfect square. Right there it is. Okay? So it's make sense? Okay. Now, let's do the C one. 48 y cubed minus 27y. Time out. We haven't done any cubes yet, have we? Well, we sort of have. Because what do you look for first? Greatest common factor. What is it? Second? Another's going to be a y. Are there any others? Oh, yes, maybe a 3y. Okay, I think that's right. So what do you get when you factor out a 3y? A little louder? 3. Okay, now pulled out just a 3. What happened to the 48? Say again? I can't hear. 16y squared, okay? Next, minus 9. Everybody see that? Are you through then? Why not? 3y is still a factor. 4y plus 3 times 4y minus 3. Y'all got it? Because see, there's our 9 right there in the square column. We knew that, okay? So now we're fully factored. All right, let's see if the book got them right. They got a 2 times x plus 5 times x minus 5, good for them. A 9 times x plus 2 times x minus 2, and a 3y times 4y plus 3 times a 4y minus 3. Good deal. And on the top of the next page is that word of caution that warns you about always factoring out greatest common factor first. It just makes life easier. We've already done that, so I think we're fine. Any questions on these three? Okay. Now, I think they have a series of other ones. All right. I think we already did that slide. Here we go. Mixing things up a little bit. Can you factor that? All right, let's start with the beginning. It's possible to apply both the technique of factoring out a common monomial factor and the pattern of difference of two perfect squares in the same problem. We've already done those. In general, it's best to look first for the common monomial factor. Okay, can you do that? Besides reading my hand? How? Is that factorable? How? Factor out of 7, not at 7x, just 7. And what you have left? X squared plus 4. Can you go any further? How? X plus 2 times x plus 2. And that gives you x squared plus 4? Oh, that gives you x squared minus 4. This is x squared plus 4. Not factorable. Remember, you can factor the difference of two perfect squares. You cannot ever factor the sum of two perfect squares. Remember that one, okay? How about this one? Is that factorable? Okay, what do you factor first? 2 xy, good deal. What do you have left? What do you have left? 2x minus 7y. Excellent. Can you factor that any further? No way. No more common factors, nothing. Okay. How about this one? How? X minus 2 times x plus 2. Very good. It doesn't matter what order you do them. Very, very good. Okay? What's that? 1 in the middle. Okay? What about it? Okay. What else do I do? Okay, no, okay, what? Oh, you just want to see it? Well, you have a question about it.
Just trying to see how you factor that.
How to factor.
Step by step, how you factor.
Okay, how I factor. Always look first for common factors, okay? So I usually first look at the numbers. Any common factor between 4 and 14? 2, okay, so I factor out a 2. Then I look at the first variable, x squared and x. Any common factors there? X and just x, okay, so there it is. I look at the next variable, y and y squared, y, so factor out 2xy, okay? What do I have left? And again, go back to your number first. 2 will go into 4, 2 times. X will go into x squared, x times, and y will go into y 1 time. So you don't even have to write the 1 down. Okay? Then go to the second. Yeah.
Part of me confused with that when I seen the x squared y.
Uh-huh.
And I thought both had to be identical to be able to factor them. I didn't know you could just say the x squared or whatever.
Uh-huh.
Then the x whatever you were using. So
Okay.
both had me confused right there. I didn't know I can do it.
All right. Now here's something, if that does get to you a little bit, try this. Rewrite this as 2 times 2, that's 4, times x. Yeah, I can't write. Okay. Okay, x times y. Okay, that's 2x squared y. Minus 14 is 2 times 7 times x times y times y. Now this is a long way to do it, but if it helps you see it, do it. Okay? Now you look for common factors. 1 and only 1, 2. 1 and only 1, x. 1 and only 1, y. So pull those out. Okay? So this will be 2x, y. You factored those out, so take out a 2 here, an x here, and a y there. What have you got left? 2x, right? And a minus sign. You factor out your 2, your x, and your y, and what do you have left? 7y. Okay? So, until you get comfortable with how it looks, you can't do it that way. Is that reasonable? Okay. And once you get tired of doing that, say, okay, I know how to do it. I don't have to do that anymore. Okay. Or you can keep doing it that way. Perfectly fine. Perfectly correct. All right? Good question. Any others? All right. Let's go to page 2 on this. Now, actually in the book, they didn't have all these. More on the slideshow. So let's see if there's some more. Yeah, here's one. Okay. Can you factor that? 18 minus 2x squared. Say again? Factor out a 2. What does that leave you with? There's no x. 9 minus x squared, right? Are you through factoring? Why not? Don't forget your 2. How about 9 minus x squared? 3 plus x times 3 minus x. Very good. Okay, how about this one? X squared plus 9. You cannot factor sum of 2 perfect squares. Very good. How about this one? No, there's nothing you can do to that one. How about that one? How? X squared plus 4 times? X squared minus 4. Are you through? Why not? Okay, this will factor, that one will not. Okay, so write down the first one, x squared plus 4 times, not 4, x plus 2 times x minus 2. Very good. Yeah, be sure you factor, okay, the square roots of those. All right, I think we got them all. Any questions on those? Always do common factors first, and then carry it as far as you can. Don't carry it any further you can either, okay? Sum of 2 perfect squares you can. However, when you're factoring either the sum or the difference of 2 perfect cubes, yes, you can. Only the difference in 2 perfect squares, but you can do the sum and the difference of 2 perfect cubes. Now, I want you to do something for me first. Give me, you can give me a number, a letter, or both. I don't care. Give me a number, or a letter, or both. Say again? 14. I don't like that. Simpler. Huh? 4x. Okay, it's going to get a little rugged, but we can do it. 4x. Okay? Give me a sign. A plus or a minus sign. Plus? Is that what I heard first? Okay, give me another, either number or letter or both. You love big numbers, don't you? Okay? A little bit smaller. 2. Okay? Do you want a letter with it or not? Doesn't matter to me. Okay. 1 letter is good enough. Okay. Now, because those are, I can actually divide something out, I'm going to change that 2 to a 3. Is that all right? Because I could factor out a 2 there and it'd be a lot easier problem. Okay. Now, I'm going to choose the next part because y'all are so difficult with me. Okay. I'm going to choose a 16x squared. I'm going to choose a minus 12x. I'm going to choose a plus 9. Okay? Now, here's the tougher part. I want you to multiply those two entities together. How would we do that? It's too big for a FOIL, but it's the same principle. It's first times first, and that would be, see your big numbers? 64 x cubed. Then do the first times the second. And what would that give you? Minus, say again? 48. No, 48, that's right. I just can't hear well. Say again? X squared. Very good. And then do the first times the third. And what does that give you? Plus 36x. Okay, now we do the second times the first. And what does that give you? Huh? Plus 48, what? X squared. First times second times the second, that gives you a negative 36x. And then second times the third is plus 27. Now I want you to add those two things together. Okay? I've set them up so it makes it pretty easy. What do you get? 64x cubed plus 27. Because these go out, those go out, they're dating. Okay, no. Okay. What do you have next? What we have is a sum of two perfect cubes. Remember? 64 is a perfect cube of 4. Okay, y'all good. Okay. X cubed is a perfect cube of X. And 27 is a perfect cube of 3. All right, very good. I didn't even have to show it. Okay. So guess what? We have the sum of two perfect cubes. And we got them from multiplying two things together. Because you multiply that times that, and you got this. So therefore, we can go the other way and factor this into that. Those two that began with. And yes? 27. You don't like my writing, do you? Okay, he's a picky person, okay? Yeah, I've noticed that, okay? He's a really picky person, making fun of my writing just because I'm left-handed, okay? Yeah, you really pick on me, don't you? Yeah. Okay, all right. That's a 27. I slashed my 7. Sorry about that. It's an old Navy habit. All right. I'm going to show you how I do sum of two perfect squares, okay? What I do is take sum of two perfect cubes. You can't do sum of two perfect squares. Sum of two perfect cubes. Take the cube root of the first one. What's the cube root of 64? 4. Cube root of x of x cubed is x. Okay? Put the same sign as you have here, plus. Cube root of 27. 3. And this is actually what I did before. I didn't tell you what I was doing, but it is. Forget about the first part. Just look at this one. Square the first term. And what's that? 4x squared is 16x squared. Now, here's the tricky part. And it's not that tricky. Opposite the product of the two. So change the plus to a minus. And then multiply the two together. And what do you get? 12x. And then you square the last term, which is a... What's that? Okay. Okay. I'm making up the formula. Okay.
I'm so serious. There's a formula for...
No, it's not really... This is a formula.
It's like A plus B, and then it's like A
okay.
minus B.
And I gave y'all the option of just giving me letters, remember? Since some people wanted numbers, okay? Big numbers, okay? Okay, so let's go back to... I like that. Let's go back to this one. A cubed plus B cubed. Is this what you want? All right. Same way, though. You take the cube root of the first one, which is A. You keep the same sign plus cube root of the second one, B. Now forget about the left-hand side. Just focus on this. Square the first, and what you get? A squared. Ooh. And then you opposite, change the plus to a minus, multiply the two together, AB plus B squared. Square the last. That's how you factor the sum of two perfect cubes. That's exactly what we're doing here. Yes. Yeah. Okay. I made it up. No, I mean, it's the rule. Square the first, A squared. Opposite the product. This is a plus here, make it a minus AB, and then square the last. That's a B squared. I'm sorry, I ran out of board there. Okay? And that's how you factor the sum of two perfect cubes. And when you give me big numbers like this, all I do is take the cube root of this, 4x, cube root, same sign, cube root of that is 3. Forget about this, square the first, that's what we did there. Opposite minus the product of the two, 12x, square the last. Plus, no, square the last number here. 3 squared. 9. Okay? And sure enough, that is where we started, wasn't it? So this is how you factor the sum of two perfect cubes. Okay? Now, gonna mess everything up here. Okay. Okay, we're going to start over almost. Okay. With somebody's big numbers. Okay. All right. Oops, I hit the wrong key. Okay, there we go. All right. You gave me before a plus sign there. All I did was change it to a minus. Okay? So I'm also going to change that to a plus. Now I want you to multiply those again. 4x times 16x squared is still 16x cubed, right? That didn't change. Okay, let's do the next one. 4x times 12x plus 48x squared. And then the first times the last. Plus 36x. Now do the second times the first, and you get a minus 48x squared. Second times the second is minus 36x. And second times the last is minus 27. Okay? And what do you have left? What does that add to? 64x cubed minus 27. Guess what? That's a difference of two perfect cubes. How do we get it? Difference of two perfect cubes. The difference of their cube roots. And then all you do, same rule as before. You square the first, opposite the product. That becomes a plus AB, and then plus the second one squared. And that's still a plus B squared. Because the second one is a minus B. When you square that, you get minus B times minus B is plus B squared. Guess what? It's the same rule. It's just you change this sign, you swap those two signs. This one's always the same as that. The middle term's always the opposite. Product is the same. So, or the factoring is the same. So you tell me what this one would be without looking at the top of the page. You're looking. Okay. Set 4x minus 3 times A little louder. 4x squared is 16. X squared. A sign. Give me a sign. Okay. What? Plus 12x. Plus, always plus. Because of minus times minus is plus. And that is what we have to begin with. That's how you factor the difference of two perfect cubes, the difference of the cube roots, then forget that and do the other stuff I just showed you. Now, what the book did is just go to this. As we pointed out before, there exists no sum of squares pattern analogous to difference of perfect squares. That is, x squared plus 9 cannot be factored at all using integers. Okay. However, the patterns do exist for both the sum and the difference of two perfect cubes. And all they did was give you the patterns, which is what my complainer over there wanted. Okay. Okay. Yeah, it is. I was hoping for that to begin with, wasn't I? Okay. Okay. So what you have from the sum of two perfect cubes, the cube root of the first, same sign plus the cube root of the second, times, forget about this, square the first, opposite sign the product, square the second. That's how you do it. Same thing here, only difference of two perfect cubes. You can do either, okay? Cube root of this, same sign, cube root of that, forget about this, square the first, opposite the product, that was a minus, make it a plus, and then plus the second square. Okay? Now, any questions on it before we go? Okay? Let's go to the example 5. Okay? Can we factor A there? That's a sum. Can we do it? Say again? Because they're perfect cubes, exactly. Okay? So what does that give us? X plus 3. Remember I said do that third column. We get to it soon. We're using them now. What's the second factor? X squared minus 3x. Excellent. Plus 9. You got it. Okay. How about B? It's also a sum. Can we do that? Ew. This is so aggravating, this thing falling around on me like this. Okay. Okay. What would that be? 2a. You're good. Plus 5b. Excellent. See, they like big numbers too, don't they? Okay. Now what? 4a squared. Excellent. Everybody see that? Next. I didn't hear a sign. Okay. Minus 10ab. Okay. And then what? Plus 25b squared. You got it. Excellent. How about C? Can we do that one? That's the difference. Can we do it? Sure, but is 1 a perfect cube? Well, yeah, 1. It is. Okay, that doesn't have to be big numbers like some people think. Okay. What would that be? X minus 1 times x squared plus what? X plus 1. You got it. You know, if you want to check these, all you have to do is multiply them together. I like to do it, but I don't like it that much. Okay. Next, how about this one? Can we do that? What would that be? 3. Y. Why not? Minus 4 x times what? 9y squared plus 12xy. Very good. plus 16 x squared. You are good. Y'all are good. Really good. Any questions on those? Got it? Now, I hate that I have to erase the first two, or the two on the left, because I just don't have much room. Okay? Let me just erase these two. I hear a lot of moving around. Does that mean something? Oh, no, it can't be. Okay, you can check in the book and see they got the right answer. Well, let's just do it quickly. Okay? First one was X. Yeah, they do extra. They are slow people. They take extra steps, but it's perfectly fine to you. And that's what they got. Same thing we had. The second one, the B one, that's the one over there. And sure enough, they got the same thing we did, 2A plus 5B. Yeah, yes, okay. Well, now we lost the whole thing, and that's exactly what we got. And the D part, after 2 steps, we did it in 1, got exactly the same thing. Good for them. They're okay themselves. Okay, that means we will start next time with example, using factors to solve equations. Okay. Let me give you a few homework exercises. We almost got through with this section. You can do any of the odds 1 through 25. Okay, I think I assigned those before. No, I didn't. It's on page 157. Last time I assigned any of the odds from 1 through 17. Now we go through 1 through 25. And then you can do any of the odds 27 through 49. And you can also do any of the odds 51 through 67. Okay? And then we'll do the rest of them next time, solving a few others. Okay, good deal. We'll see you Wednesday. Very good. All right. Hope you don't mind me giving you a hard time. No. All right, good. All right, good. Okay. Did you have problems on any of them?
No, I was just
Okay.
sick Wednesday.
Okay, well then, if you have problems, I'll be glad to go over them with you, but if not, keep them for your
I
study.
emailed you about the homework assignments. I know how to do most of it.
Right.
I just need to know the assignments. So I've been here for 3 classes. I'm
Right.
walking pneumonia.
Right, I remember, I emailed you back. So,
Oh, you did?
Yeah.
Okay.
It's
Is the
all on
assignments just in
screen.
there?
Yeah, but it's all on screencast-o-matic, that's what I said.
Okay. Well, I don't know
Just
how
like
to
I
get
did
to
today. Oh, you just, explain that too. You go to Blackboard, okay?
Yeah.
Go to Content. Yeah, this course in Blackboard, Content. I have there the syllabus, I have the research paper instructions, I have my locator card, I have all the PowerPoints, and then various sites. The last thing on there says Math 100 YouTube videos. And if you go to that, you get to
Okay.
pick out
That
any
makes it
of
a
them.
lot easier. All right. Thank you.
Okay, surely. Yes, sir. Yes, ma'am. Oh, right. Good deal. Look at that. Okay. All right.
It's okay if I did it on him. I was going to do it on another mathematician, but
That sounds great to me. Yeah. Yeah, and I think you're the first one to choose it, so you go with yours. Okay.
And on the research paper, did you say it has to be, it can be one source, or it has to
Yeah,
be?
one is fine. 2 or more is better, but one's fine. Yeah.
And like we can use like the internet, like something off the internet?
You can do that as long as you're real careful that you make sure it's a good site, not just somebody's opinion that, you can't factor x squared plus 7,
Yeah.
No, you can't, so make sure it's something that's good. And I'm recording all that, so.